Welcome back to STEAM Club Online. As always, it's me, Matthew, but with me today I have Jake, who also works in our library. Hey! Last week we did our bottle rocket experiments, and we're looking forward to see how you guys did with yours, but for this week we're looking at liquid density. We're going to look at how different liquids interact, or hopefully not interact with each other, with our experiment. So, let's get started. What you're going to need today.
Alright guys, so first off, you're going to need some jugs. You're going to need a turkey baster. If you don't have one of these, you can use either a plastic syringe or an eyedropper, or much anything, as long as you've got control over the liquid coming out.
Old sauce bottle.
Good one. You're also going to need some maple syrup, some baby oil, some honey, some dishwashing liquid, some vegetable oil, and a few little odds and ends to test the buoyancy. Today, we are using a paper clip, a coin, a pen lid, a marble, an eraser, a small pebble, and a bulldog clip. Make sure all your ingredients and all your equipment are nice and dry, they're not wet, and there's no dirt on them.
When you do the experiment today, you need to make sure that you drop the ingredients into the center of the jar to make sure nothing gets on the side. If any of the liquids get on the side of the jar, it will ruin the experiment. So, we need to fill the jar, and that's what we're going to do now. So now we have our different layers. We started with honey, we skipped the maple syrup and we tried golden syrup because we found our maple syrup was too runny. Then we moved on to dishwashing liquid, water, vegetable oil, then baby oil. And if you can see, and we'll post a clear photo of this up as well, you'll be able to see the clear different layers. If you want to do this at home, for some of them you can add like food coloring to the water layer to change the color for a distinct different one. Now, why did this happen? The answer is density. Now, the equation for density is this. Density equals mass over volume. So it's how heavy something is over how much area it fills up. Now, what that basically means is stuff can be heavier than other things. For example, this is 750 grams of bread, minus a couple of slices because I got peckish. And this is 850 grams of golden syrup. Now you notice how much smaller the golden syrup is to the bread. It's to do with density. This is much thicker. There is much more content over a smaller area than the bread. Now this can happen in liquid as well. Now this equation for density, density is mass over volume, and this one is referring to physical density. This isn't actually the equation for liquid density, but those get a lot more complicated a lot faster. And for now, we just want to introduce you to the concept of density, not getting too worried about all the equations at the moment. Now, we have various objects around that Jake got, and what we're going to do now is the second part of our experiment. We're going to see how these objects sit in this various density liquid. Now, I know why, so I'm going to ask you if you have any guesses why stuff is going to sit differently than anything else. And write it down, talk to your parents, have a look, have a guess, and we'll talk about it afterwards. For now, I'm going to hand it over to Jake. We're going to drop these objects in, and we're going to have a little fun.
Thanks, man. Alright guys, so we've got the objects that we stole from around the office earlier, and we're going to drop them in one by one, and we're going to kind of guess where they'll float or sink in the layers. So Matthew, where do you think the paperclip is going to land?
I think the paperclip's going to stop at the dishwashing liquid.
Pretty good guess. Mine's probably around the second layer of oil. We're both wrong.
That's at the water. We were both wrong.
Sure were. Now this one's a little bit more dense. This is an eraser.
I would try dropping this closer to the water, just so you don't have a splash and everything mixed in together, because you want to see where it actually lands to the other liquids.
Correct. So you want to get as close as you can to the liquid, and you're going to very, very carefully drop it in. There we go, Matt.
It stopped at the honey.
There we go. An eraser is not thicker than honey.
No.
Cool. Next up is a small pebble. I have a feeling it's going to be about the same.
I'm not sure. I think it might stop at around the dishwashing liquid.
Nice. Let's test it.
And due to the colour of the pebble, I can't really see where that went.
It's vanished. Doesn't
Actually-
exist anymore.
No, it went into the honey.
There we go. Honey. Alright. We have our little plastic marble next. What do you reckon?
I'm going to say that's going to float on top.
This one I reckon is going to be very hard on the top as well.
Ah!
There we go. I reckon was that
Dishwashing liquid, yeah.
Dishwashing liquid. Next up, we have a pen cap.
I'm going to say it's going to stop at the same point.
Yeah, I think so too.
Ah!
We're often wrong. It's at the very top.
The baby oil.
Baby oil, denser than the pen cap.
Yeah.
Cool. Next we have a coin.
I have no idea.
This one's anyone's guess.
That one is below the honey. It's denser than
Right
the
to
honey.
the bottom. Wow.
Now, did any of your guesses line up with ours? If so, congratulations, you were wrong. Did any of you actually get the correct answers? Because we did this without knowing and dropping in first. If you did, congratulations.
There are no prizes.
Yeah. Now we have to figure out the answer to why. Why did this happen? Buoyancy is upward thrust. It is the force placed on an object upwards due to the pressure differential in liquid. Sounds complicated. But basically, with any liquid, the more that is on top, the more weight on top, the more pressure applies to the bottom. Right? And so when you put a liquid in a container, the bottom is going to have a lot more pressure than the top. When you put an object in, what's going to happen is, if it's partially or fully submerged, there's going to be more pressure on the bottom of the object than there is on the top, which means that there is going to be a force pushing it up. So why stuff floats here is because of the weight of the object interacting with the pressure in the liquid, so the upward thrust. Now, if an object floats, it is less dense than the liquid. If the object submerges but doesn't float or sink, it is the same density of the liquid. And if the object sinks through the liquid, it is denser. For example of this, and an easy one you can do with not many things, all you're going to need is some water and a ping pong ball and a marble. The ping pong ball will float, the marble will drop to the bottom of the glass. That's all we have for this week. We'd love to look at the comments and see what liquids you've chosen and your various experiments. Remember, comment, ask us questions if you want, and we'll be sure to answer the best that we can. So, I've been Matthew.
I've been Jake.
Have fun, and remember, for science! And help your parents clean up.